Yes, now students, in exercise 1.1, the last question. So what he has given, see here, show that one and only one out of n plus 2 or n plus 4 is divided by 3. So where n is any positive number. If n is any positive number, if we consider n plus 2, n plus 4, out of these 3 only one number is divided by 3, that we have to prove. Then how to prove? See here, when we divided with 3, so we will get 3 remainders. So what are the remainders? When we divide with 3, so we will get first 0 as a remainder, 1 as a remainder, 2 as a remainder. So total 3 remainders you will get, that is from 0, 1, 2. So 3 remainders you will get. In the solution, when we divide with 3, we will get 0, 1 and 2 as reminders, as reminders. Okay. Now from Euclid division lemma, so if you take n, so that is if you divide with any number, any positive number, so then you will get, if you take n is a positive number, if you divide this n, so then 3q, so it divides with 3q plus 0 according to Euclid division lemma. So when n, again the n is divided with, so 3, the remainder is 1 according to Euclid division lemma. So again the positive number n is equal to 3q plus 2. So when the remainder is 0, then 3q plus 0, n is equal to 3q plus 0. When we divide n with 3, when the remainder is 0, then according to Euclid division lemma, n is equal to 3q plus 0. So that is dividend is equal to divisor into quotient plus remainder. Now, so dividend n is equal to divisor into quotient plus remainder 1. So dividend is equal to divisor into quotient plus remainder 2. Okay. Here n is equal to 3q plus 0, it means n is equal to 3q, n is equal to 3q. So here n is equal to 3q, here remainder is 0, means here 3 divides, only 3 is a quotient. So 3 multiple, 3 into q, 3 multiple is getting, if 3 multiple we are getting, it means 3 divides, 3 into q, 3 into q plus 0 means that is 3q, it means this is 3 multiple. Whenever 3 multiple is there, so that means 3 divides. Then after that, here 3q plus 1, here 3 multiple is there and plus 1 remainder is there. So no chance, here 3 is not divided by this n. Here 3q plus 2, here remainder you will get 2. So here you won't get, so you won't divide with 3. Why? Because here 2 is a remainder. Then after that, about n is over. Now if you take n plus 2 in all the 3 cases, then what happened? Here, say n plus 2 means add plus 2 on both the sides. Then what happened? See here, n plus 2 is equal to 3q plus 2. 3q plus 2. Here n plus 2 is a positive integer, 3q plus 2, here 3 multiple is there and remainder plus 2 is there. So here 3 is 3, it is not divided by, it's not divided by 3, it is not divided by 3. Now here also add plus 2 on both the side, add plus 2 on both the side. on both the sides, that is n plus 2 is equal to 3q plus 1, same 3q plus 1 and add plus 2, add plus 2, okay, plus 2 here and plus 2 here, n plus 2, 3q plus 1 plus 2. Now n plus 2 is equal to 3q plus 1 plus 2 is 3, then n plus 2 is equal to 3 common, if 3 common then q left and plus, if 3 common 1 left. So this is 3 multiple, total 3 multiple we are getting. So here the 3 multiple is given, 3 multiple is there, so it means 3 divides, here 3 divides. So 3 divides, here 3 divides, okay. So in the first case here it's not divided by 3, it's not divided by 3, it's divided. Now here add plus 2, it's not divided here, it's not divided by 3, it's not divided by 3. Now here also plus 2, add plus 2 on both the side, add plus 2 on both the side, add plus 2 on both the side, that is n plus 2, here 3q plus 2, 3q plus 2 already there, 3q plus 2 is already there, we are adding plus 2, again one more plus 2. So we should take this as it is, plus 2 here and plus 2 here, plus 2 here and plus 2 here, we should add plus 2 on both the side, that is n plus 2 is equal to 3q plus 2 plus 2, 4, n plus 2, 3q, 4, how to take 4, that is 3 plus 1, 3 plus 1 is 4, then n plus 2. In these two 3 is common, if 3 is common then what is left, q plus 1 and this plus 1 as it is. So till here we have 3 multiple and plus 1 is there, it means plus 1 is a remainder. So it means, so it's not divided by 3, it's not, it is not divided by 3. Then about n is over, about n is over, about n plus 2 is over, here about n is over, about n plus 2 is over, about n is over, about n plus 2 is over, n is over, n plus 2 is over. Now after that n plus 4. So now we go for n plus 4. Again in this add, so plus 4 on both the side. So add plus 4 on both the side. Then so that is n plus 4 in the first one. In the first one we should add. So that is n plus 4. N plus 4 is equal to 3q plus 4. Then n plus 4 is equal to 3q plus 3 plus 1. N plus 4 is equal to 3 common in these two. 3 common, then q plus 1 plus 1. Here we are getting 3 multiple and plus 1. Plus 1 means remainder left. So it is not divided by, it is not divided by 3. It is not divided by 3. Here it is not divided by 3. This is n plus 4 is over. In this, the first one n is equal to 3q, it is divides, it's not divides and it's not divided. Only one number divided, only one number divided, that is n. N divides. n plus 2 and n plus 4 is not divisible by 3. Only one of the number is divided by 3 he is asking. Only one of the number in the first case, that is 3 is n is equal to 3q, that is divided. Then here also add plus 4 on both the side in this equation first, that is n plus 4 is equal to 3q plus 1 plus 4, then n plus 4, that is 3q plus 5, 1 plus 4 is 5, then n plus 4 is equal to 3q plus 3 plus 2, 3 plus 2 is 5, n plus 4 is equal to, in between this 3 is common, q plus 1 is left and plus 2. Here 3 multiple, we are getting 3 multiple and plus 2. Plus 2 means remainder, we left remainder. So it's not divisible by 3. It is not divisible by 3. So in the next, here also we should add plus 4 on both the side. Add plus 4 on both the side. Add plus 4 on both the side, that is n plus 4 is equal to 3q plus 2 plus 4. Add plus 4 on both the side. N plus 4, 3q plus 2 plus 4. Now n plus 4. 3q plus 2 plus 4 is 6. N plus 4. 3 and 6 are the multiples of 3. Then you can take 3 as a common. If you take 3 as a common, 3 ones means q left, 3 twos are 6. Here 3 multiple we are getting, there is no plus here, there is no remainder. It means it divides. It's divisible. It's divisible by 3. So this is our third positive number. This is our third positive number. See here, in the 3 cases, in the first one n is equal to 3q is divides. In the second one n plus 2 divide. In the third one n plus 4 divides. Any one number only divided by 3. Any one of the number is divided by 3. See here, first what we should take? We should take here, according to that, n is a positive number. So that positive number is divided by 3. When the number is divided by 3, then we will get 0, 1, 2 as a remainders. When we divide any number, so we will get 0, 1 and 2 as a remainders. According to that, on the basis of that, n is a positive number. N is a positive number. When we divide with 3, the remainder is 0. When we divide with 3, remainder is 1. When we divide with 3, remainder is 2. These 3 cases. It means here remainder is 0 means here 3 divides. Here remainder 1 means it is not divided by 3. When the remainder is 2 means it is not divided by 3. Only the first one divided by 3. After that, about this n, one of the positive number, that n is over. Now the next positive number n plus 2 we should take. N plus 2. N plus 2 means plus 2, add plus 2 on both the side. When we take n plus 2, so we should add plus 2 on both the side. Then you will get n plus 2, 3q plus 2, n plus 2, 3q plus 2, 3q plus 2 here. N plus 2 is equal to 3q plus 1 plus 2. N plus 2 is equal to 3q plus 2 and plus 2 again. So n plus 2 we should take n plus 2 same. Plus 2 add, then you will get n plus 2, 3q plus 2. So n plus 2, 3q plus 1 plus 2. So then n plus 2, 3q plus 2 and plus 2 you will get. Then simplify it. Here n plus 2, 3q plus 2. Here remainder is 2. So it is not divided by 3. Here n plus 2 is equal to 3q plus 1 plus 2. If we simplify, n plus 2 is equal to 3q, 1 plus 2 is 3, then n plus 2. In these 2, 3 is a common. When you will get 3 as a common, then you left q plus 1. Here you will get nothing, no remainder here, 3 into q multiple. 3 into q multiple we are getting, so that means it is divided by 3. Here n plus 2 is equal to 3q plus 2 plus 2. Add plus 2 on both the side. then n plus 2 is equal to 3q plus 4. N plus 2 is equal to 3q plus 4. How to take plus 4? That is 3 plus 1. Then n plus 2 is equal to, now you take 3 as a common, then q plus 1. Then after that 1 remainder is left. It means it is not divided by 3. So in n plus 1 positive, n plus 2 positive number, in the second case it is divisible by 3. In the rest of the two cases, first and second, it is not divided by 3. Then the next n plus 4, take n plus 4, means plus 4, add plus 4 on both the sides. N plus 4 is equal to 3q plus 4. Then n plus 4 is equal to 3q plus 4 means 3 plus 1 we can take. N plus 4 is equal to, in between these two, 3 as a common, then you can left 3 plus q plus 1, then plus 1 as it is. Then plus 1 left here means as a remainder it is not divided. Then here also plus 4, if you add plus 4, then n plus 4 for equation first. N plus 4 is equal to 3q plus 1 plus 4, 3q plus 1 plus 4, n plus 4 is equal to 3q, 1 plus 4 is 5. Again you split this 5 like 3 plus 2. Now n plus 4 is same, in between these two 3, take 3 as a common, then you left q plus 1 and plus 2. Here plus 2 is a remainder. When plus 2 remainder is there, that means it is not divided by 3. Now, so in the last case also add plus 4 on both the sides, that is n plus 4, 3q plus 2 plus 4, 3q plus 2 plus 4. Now n plus 4, 3q same, 2 plus 4 is 6. Then n plus 4 is equal to 3 common here, 3 and 6 both are the multiples of 3. Then we can take 3 as a common. Then q plus 3 2s are 6. So here we are getting 3 multiple. When we are getting 3 multiple, then it is divisible by 3. It means in the first case when n is equal to 3q, it is divided by 3. So in the second case when n is equal to n plus 1, n not n plus 4, n plus 2. N plus 2 positive integer is divided by 3. In last case n plus 4 positive integer is divided by 3. In first one, n is a positive number which is divided by 3. In the second case, n plus 2 positive number is divided by 3. In the third case, n plus 4 positive number is divided by 3. This is the method to check only one of the number in n, n plus 2, n plus 4 is divisible by 3. Okay. So now the students see here fundamental theorem of arithmetic. So what is fundamental theorem of arithmetic? See here. So a is equal to bq plus r. So a is any positive integer. So b is the divisor and q is a quotient and r is a remainder. A is equal to bq plus r. If it is like this, means b is a divisor. So when b is a divisor, so then how the remainder is? The remainder is in between 0. 0 is less than or equal to b, remainder is less than b. It is like this. So how it is? Suppose, so if 5 is there, 5 is equal to, suppose any number is there, a is any positive number, a is equal to 3q plus r, 3q plus r. Here we are dividing with 3. Here 3 is a divisor. When 3 is a divisor, then how the remainder is? How the remainder is? The remainder is in between 0 to less than 3. 0 to less than 3. 0 is less than or equal to means 0 also we should consider. We should consider 0. Here only less than is given. There is no equal nothing. Means don't take 3. Means our remainder is r is 0, 1, 2. Till 2 we should take. When we divide with 3, the remainders are from 0 to less than 3. From 0 to less than 3. 7 when the remainder is 3. Here also the same. If the remainder is b, if the divisor is, if the divisor is b, how the remainder is? The remainder is 0 to less than b. 0 to less than b. Like when the divisor, here divisor is 3, the remainders are 0 to less than 3, like that 0 to less than b, 0 to less than b. Here b is a divisor. When b is a divisor, the remainders are 0 to less than b. When divisor is 3, the remainders are 0 to less than 3. So in that way, So, our arithmetic, so the fundamental theorem of arithmetic, what it shows, so it reflects when a means any positive integer is divided with b, then how the statement will come. A is equal to bq plus r, a is equal to bq plus r. So, where our r means our remainder, how the remainders will come. So, that is from 0 to less than b, that is from 0 to less than b. If suppose the remainder is 0, then what it will be? A is equal to bq plus r, a is equal to bq plus r, r is 0. If r remainder is 0, then a is equal to bq plus 0, then a is equal to bq, a is equal to bq. So, what is the statement? A is equal to bq is the statement. So, then what about the relation between a and b? So, a and b relation is b is a factor of a, b is a factor of a. How it is a factor? Suppose 24, if you take 24, how to take 24? 6 4s are 6 into 4, 6 4s are 24, remainder is 0, means 24 is equal to 6 into 4. 6 is a factor of 24, 6 is a factor of 24. If you write all the prime factors of this 24, then how to take prime factors? 6 means 2 3s are, and 4 means 2 2s are. So, then 24 is equal to 2 into 2 into 2 into 3. So, then 2 is a factor of 24 and 3 is also factor of 24. 6 is also factor of 24 and 4 is also factor of 24. So, whatever here are there, so that are factors of 24, means in the same way, if a statement is like this, a is equal to bq, means the divisor is factor of dividend, the divisor is a factor of dividend, and also the quotient also a factor, b is also a factor of a and q is also a factor of a when remainder is 0. When remainder is 0, divisor and as well as the quotients are factors of dividend. Okay. So, this is about fundamental theorem of arithmetic. Okay, students. So, now the students, in the fundamental theorem of arithmetic in 2.1, see here 1.2. So, 1.2, so this is our fundamental theorem of arithmetic. So, what is the statement given? So, according to fundamental theorem of arithmetic, every composite number can be expressed, means factorized, so as a product of primes, So, whatever the composite number is there, so that we can express as a prime product of prime factors, and whatever the expression, that is the prime product expression, so that is a unique. So, that is unique for every composite number. Apart from order in which prime factors occur. So, how? So, means how the order means, so whenever the composite numbers are there, so when we split into prime factors, so we should arrange the prime factors in order from smaller to bigger. So, that is a unique, for that particular number. So, that is not same for other number. So, that is unique, that is different. Every composite numbers have different prime factors, he is saying. So, for example, in your textbook he has given 210 prime factors, he splits into prime factors. How he splits into prime factors? See here. So, 7 3s are 21, 7 30s are, so 210. So, if again we split into prime factors, 7 is a prime number, so no need to split further. So, then 30 is a composite number, again we can split, that is 215s are. 7 and 2 are the prime numbers, then 7 into 2 same, and 15 is a composite number, then we can split this 3 into 5. Now, if we check, so the product of these numbers, how the numbers are? 7 is a prime number, 2 is a prime number, 3 is a prime number, 5 is a prime number, all are prime numbers. So, 210, so this is a composite number. Composite numbers can be expressed, so as a product of prime numbers. First we should write a smaller number, and after that bigger than this 3 and bigger than this 5, and bigger than this 7. So, this composite number 210 we can express as a product of prime factors, prime numbers. So, as a product of prime numbers, and whatever the product of prime numbers, this is unique for this 210. So, this is unique for this 210 only. So, if you multiply these 4 numbers, you will get 210 only. If you add other numbers, you will get other composite number. So, that is why, so whenever prime numbers are there, so whenever we have a prime numbers, so that means that prime number, whenever the product of prime numbers expressed as a product of composite numbers, that method is unique for particular composite number. So, that method is unique for particular composite numbers. So, whenever we are arranging in order how? So, that is your wish. So, from smaller to bigger or bigger to smaller. So, that is a unique method for particular composite numbers, particular composite number. Okay, okay students. Yes, now students, in example 3. So, what is the question? See here, consider the numbers of the form 4 power n, where n is a natural number. Check whether there is any value of n for which 4 power n ends with 0. 4 power n ends with 0. Here 4 power n is given. So, here n, the power, the exponent is a natural number. Exponent is a natural number, any natural number. So, for any natural number, so the value of n, so ends with 0 he is asking. Either for any value of n it ends with 0 he is asking. See here, so first of all we should take 4 power n. So, given 4 power n. So, what is given here? 4 power n. Now, if we split 4 into prime factors, then how it is 4? So, we can take 2 into 2. 2 into 2 is 4 and whole power n as it is, whole power n. Then 2 into 2 means 2 square, 2 square whole power n, 2 times, that is 2 square whole power n. Then 2 into 2 square whole power n means a power m whole power n form, a power m whole power n, that formula is m into n. 2 power 2 whole power n is 2 into n, 2n, 2 power 2n. Here the base is 2. If the base is, so in the product in the form of 5 and 2 products, so then the number ends with 0. This you should keep in your mind. So, what students, if the prime factors here the prime factors of a number are 5 and 2, 5 and 2 are the prime factors, means product of the prime factors, then the number, the power of the number ends with 0, otherwise it won't end with 0. Okay. Here, if the product of prime factors of the base are 5 and 2. So, if product of the prime factors of the base are 5 and 2, then the power, then the exponents ends with exponents expansion, then exponents expansion ends with 0. So, here the base is 2 only, here the base is, so for any natural number of n, 4 power n, so did not ends with 0. okay, did not ends with 0. If the base is in the product of the prime factors 5 and 2, so then the 4 power n, so expansion ends with 0, otherwise it won't ends with 0. This is the answer. This is the answer. So in the short way we can say either it is ends with 0 or not. So just we expand, just we should find the prime factors of this base. If the base prime factors are in terms of 5 and 2 prime numbers in the product of 5 and 2's, then the expansion ends with 0, otherwise it won't ends with 0. Okay. Now the fourth example, find the LCM and HCF of 12 and 18 by the prime factorization method. By using prime factorization method, we should find 12 and 18 LCM and HCF. Then how to find? See here, first 12 and 18 prime factorization means product of prime factors. First, this is an even number, so it is divided by 2 prime number, 2 6 again 6 is a prime number, so this is also divided by 2, 2 3 3 is a prime number, so end till here. Okay. 18 is a prime number, so 18 is a composite number, so it is an even number, it is divided by 2 prime number, 2 9s are 18. Again this 9 is divisible by 3 3s are. Then again this last 3 is a prime number, so stop till there. Now 12 prime factors, 12 prime factors, so that is product of prime factors, 2 into 2 into 3, product of, don't take prime factors, product of prime factors, product of prime factors, right, prime numbers, so that is 2 into 2 into 3, 2 into 2 into 3, 2 into 2 into 3. Now so 18 product of prime numbers, so then 2 into 3 into 3, 2 into 3 into 3. Now 12 and 18 LCM. So LCM, so how to find LCM? LCM means in these 2 product of prime numbers, 2 is common in both, 1 3 is common, so then whatever the common multiples are there, so that we should take one time, 1 2 common and 1 3 common, 1 2 is common and 1 3 is common, so that you take 2 into 3, 2 3s are 6, 6 is the LCM, Now 12 and 18 LCM, not LCM, HCF. Now HCF, highest common factor. Then how to take HCF? First, whatever the common are there, so just you take one time that, like 2 into 3, like LCM. Whatever the LCM that you should write, and whatever the numbers left, that numbers again we should write. So here 2 is left in the first number, in 18 3 is left, that also we should take. The common numbers we should take one time, like LCM, and whatever numbers are left, that you should write again. Now you find the product, 2 3s are 6, 6 2s are 12, 12 3s are 36. 36 is the HCF and 6 is the LCM. In the LCM, so whatever the numbers are common, so that number we should take one time and find the product. Okay, 2 here 2 and here 2 is common, means that 2 we should write. So 3 and 3 is common, means that one time we should write 3 and find the product. 2 into 3, 2 3s are 6, that is your LCM. And HCF, in the HCF again whatever is the common, so that we should write, and whatever those numbers left, so again that number product also we should find, and total find the product of all. So then whatever the product will come, so that is your HCF. This is the method to find LCM and HCF using prime factorization method. Okay students. So now the students see here in exercise 1.2, the first question, express each of the following numbers as a product of its prime factors. So we should write the given numbers as a product of its prime factors. See, so what is the easiest method to write prime factors? First we should take 140. So we should take as a product of prime factors. So write like this. So here last is 0. 0 means it is divisible by 2. Now you take 2. 2 7s are 14 and 0 as it is. Again 0 is there, it means it is an even number. Again we should take 2. 2 3s are 6, 1 left. 2 5s are 10. So then after that 5, here 5 is there. 5 is a prime number. So it is divided by 5. 5 is divided with 5 and last unit digit is one's place is 5. It is divided by 5. 5 7s are 35. Again here 7 is there. 7 is a prime number. So no need to do further. Now you stop till here. Then 140. So how to write as a product of prime numbers, prime factors? 2 into 2 into 5 into 7. 2 into 2 into 5 into 7. So this 140. So as a product of prime factors, 2 into 2 into 5 into 7. Okay. Now the next number is 156. 156. The last one's place is 6. It means it is divided by 2. 2 table with 2. 2 7s are 14. Here 15 means 1 left. 2 8s are 16. Again here in one's place even number is there. So divided by 2. Then 2. 2 3s are 6 means 1 left. 2 9s are 18. So then 39. 39 is divided by 3. So now you take 3 prime number. 3 1s are 3. 3 3s are 9. 13. So 13 is a prime number. So no need to do further. Stop till here. So then, 156. How to write product of their prime factors? That is 2 into 2 into 3 into 13. 2 into 2 into 3 into 13. So this is the product of prime factors. So then after that 3825. Then how to write product of prime numbers? So 3825. So last one's place is a 5. So it is divided by 5. 5 7s are 35. 3 left, 32. 5 6s are 30. Again 2 left, 25. 5 5s are 25. Here again 765, in that one's place is 5. It is divided by 5. Again take 5. 5 1s are 5, 2 left. 5 5s are 25, 1 left. 5 3s are 15. 153. This 153 is divided by 3. So now divided with 3. 3 5s are 15. 3 1s are 3. Again this 51 is divided by 3. Again take 3. 3 1s are 3. 2 left. 3 7s are 21. 17. Here 17 left. Here 17. 17 is a prime number. So no need to do further. Stop till here. Now 3825. 3825 is the product of prime numbers. 5 into 5 into 3 into 3 into 7. So first you write smaller numbers, that is 3 into 3, again 5 into 5, after that 17. So this is about the product of prime numbers. Okay. Then after that 5005. Then have to write 5005 as a product of prime factors. 5005. Now, so 5005 in the ones place 5. 5 means it is divided by 5. Take 5. 5 ones are 5. 0, again 0 same. 5 ones are 5. 1001. 1001 is divisible by 11. Now you take 11. So means 100 we should take. 11 nines are 99. 11 nines are 99. 1 left. 11 ones are 11. 11 ones are 11. So now this 91. 91 is divided by 7. 7 ones are 7. 2 left, 21. 7 threes are 21. Then 13. So 13 is a prime number, no need to do further. So now you stop. Then write 5005. So as a product of prime factors, that is, so 5 into 7 into 11 into 13 in order. 5 into 7 into 11 into 13. So this is about the product of prime numbers. Okay. So whenever he asks to write the given so and so number as a product of prime factors, means first we should think in which table it divides. So here we should take prime numbers only. We should divide with prime numbers only. No need to take composite numbers. You should take prime numbers and divide. So why he is asking? He is asking so the product of prime numbers. So that is why we should divide with prime numbers. Okay, students. Okay. Now students, see here. The next question is 7429. 7429 prime factors we should write. 7429. So then first we have to check with 2. So here in ones place odd number is there, so it won't divide with 2. Then with 3, the sum of the digits 9 plus 2. 9 plus 2 11, 11 plus 4 15, 15 plus 7 22. 22 is not divided by 3, so the number is also not divisible by 3. So then with 7 also it won't divide with 7. So then after that with 11 also it won't divide. So then after that with 13. So with 13, so 13 also it won't divide with 13. Now with 17 it divides. 17 437 za. 17 437 za. So 7429. Then after that 437. So now we have to check 437. 437 in which table it divides? So in 19 table. In 19 table it divides. 19 23 za. 19 23 za 437. So now after that 23. 23 is a prime number, so no need to do further. So stop till here. Now you should write product of prime factors of a given number 7429. So that is 17 into 19 into 23. 17 into 19 into 23. This is about the product of prime factors. Whenever he is asking to write the product of prime factors, so the given number should divide with the prime numbers only. No need to do with composite numbers. Don't divide with composite numbers. You should do with prime numbers. Take prime numbers and see so in which prime number they divides. With that number, so you should divide and write your answer. Okay. Now, the next second question. Find the LCM and HCF. Find the LCM and HCF of the following integers by the prime factorization method. Using prime factorization method, we should find LCM and HCF. See here, so how to find LCM and HCF? First 12. 12 we should take it. These are the small numbers, so it is very easy to. So write prime factors. So 2 2s are 4, 4 3s are 12. 12 prime factors, product of prime factors 15. 3 5s are 15. Now 21. 3 7s are, all these are prime numbers. Product of prime numbers 3 and 7 prime numbers, 3 and 5 prime numbers, 2 2 3 prime numbers. So like this only we should take prime numbers, product of prime numbers. Now 12 15 21 LCM, 12 15 and 21 LCM. So how to take LCM, how to write LCM? So what is common in all the three? So 3 is common, 1 3 is common in all these 3. 1 3 is common, 3 is there, 3 is there, 3 is there. Only 1 3 is common. So here 2 is there, but here we don't have 2. Here 5 is there, we don't have 5 here. Here 7 is there, we don't have 5 in all 3. So only 3 is common in all these 3 numbers. So LCM is 3. LCM is 3. Now 12, 15 and 21 HCF, highest common factor. Then how to write highest common factor? So first one time, so 1 3 is common, so that we should take, and remaining number here 2 2s, 2 into 2, and here 1 5, and here 7 is left, here 7, okay, into 7 into 7, 1 7 also we should take. Here in all the 3, so 1 3 is common, that we should take 1, and 2 2 is left, that we have to write. Here 1 5 is there, that 5, and here 1 7, that 7. Now so what is the product? 3 2s are 6, 6 2s are 12, 12 5s are 60, 12 5s are 60, 3 2s are 6, 6 2s are 12, 12 5s are 60, 67 are 420. HCF is 420. What is the HCF? 420 is the HCF. Okay. In the LCM, whatever is the common in all the 3, that we have to write, and in HCF whatever is the common, that we have to take, and rest of the numbers 2 into 2 whatever left, that again we should take in the product form. So then after that you find the product, that you will get HCF. Okay. Now here first 17 prime factors, 17 ones are 17, then 23 is a prime number, then 23 ones are 23, here 29 is also prime number, no other common factors, then 29 ones are 29. So then, so what is the LCM? So here 17, 23 and 29 LCM. Nothing is common in all, so only one common is there. So if nothing is common means one is common in all. So that we have to take as LCM. So not LCM, this is okay, this is HCF. So HCF, highest LCM, this is HCF. HCF is 1. Here also, sorry, this is the HCF. The first one is the HCF here. This is HCF, this is LCM. This is HCF. HCF means whatever is the common in all the 3, that we have to write. And in LCM, so whatever is the common, that we have to write once, and the rest of the numbers we should take in multiplication form and find the product. So that is your LCM. So HCF means whatever is the common in all the 3. So that we have to write. Whatever is the common in all the 3, so that is 1. 1 is the HCF. Now after that LCM we have to find 17, 23 and 29 LCM. LCM means 1 is already common, so that if you want to take, otherwise just you multiply whatever is left. 17 into 23 into 29. The product of all the 3 we should find. That is our LCM. So then first you multiply in rough column 17 into 23, 17, 23, 3 sevens are 21, 2, 3 are 3, 4, 5, 2 sevens are 14, 2 are 2, 3, 391. Again we should multiply with 9, 29, 9 ones are 9, 9 ones are 81, 8. So 9th is at 27, 27, 8, 35. Now after that 2 ones are 2, 2 nines are 18, 1 to the 6, 7. Then 9, 3, 13, 11. 11,339. So 11,339. This is the LCM. So what is the HCF? So HCF means whatever is the common in all the three, that is the HCF. And what is the LCM? LCM means so whatever is left after taking common. If 1 is common, we won't take 1. So why? Because if you multiply with 1, so then the same thing only you will get. So that is why we won't take here 1. So other than 1, if any number is there, that number also we should take. So here 1 we are not taking it. That doesn't mean that so no need to take that 1. Take that any common number. So like here common is 3, so that we took here. Why? If you multiply with 3, the number, the product will come here. If you multiply with 1, the same product you will get. So that is why so we won't consider 1 here. Okay. Now 8 prime factors, 2 into 2 into 2, 9 prime factors, 3 3s are 9, 5 prime factors, 25 prime factors, 5 5s are 25. Now after that else first we have to take HCF, 8, 9 and 25. HCF, highest common factor. Here nothing is common in all, so they are different. Nothing means into 1 we should write, into 1, into 1, into 1. So it means 1 is common in all. So 1 is the HCF. If nothing is common in all means so 1 is common. So 1 is common. So as a HCF. Now 8, 9 and 25 LCM. So just to multiply all, 8 into 9 into 25. So now, so 8 9s are 72, 72 with 25, 72 with 25. Now you multiply 72 with 25, 25 2s are 55. So 25 7s are 175. So 175 plus 5, 180, 180. That is 1800. This is our LCM. This is our HCF. HCF means if won't get common in all the three means 1 we should take common. So then LCM means after taking all, so whatever the elements left, that we should find as a product. So how? 2 into 2 into 2, that is 8. 3 into 3, that is 9. 5 into 5, 25. Or otherwise if you write in detail 8, how to take 8? 8 means 2 into 2 into 2. 9 means 3 into 3. 25 means 5 into 5. Now 2 to the 4, to the 8, 3 the 24, 3 the 72, 5 has a 25. Now you multiply. So that is you will get 1800. So this is our LCM, this is our HCF. Here also we won't consider 1. Why? Because if you multiply with 1, so if you multiply with 1, the same number you will get. So that is why no need to take 1. When 1 is there in common in all, so no need to take 1 in HCF. Into 1, no need to take. Then if other than 1 as a common number is there in all the given numbers, then that number should take in HCF in the product. Okay. This is the method to find LCM and HCF. Here LCM and HCF. Once again, what is LCM and what is HCF? LCM means HCF first. HCF means whatever is a number in a product common in all the given numbers, that is the HCF. And LCM, so whatever is the number common, that number, and so whatever the numbers are left, that we should take. So product of all that numbers, that gives us HCF. Okay, okay students.